So I'm here at Nicholas CORREA in Burgos at their factory. In fact, this is about the fourth or fifth time I've been here, Javier, in the last 10 years. But one of the reasons I'm here, and it's quite significant to see some changes that have happened in the industry really, and what's obviously led to us being here to shoot this, automation on larger machines. Now, it goes without saying, around the world, the smaller machines, automation has been something that's been integrated for a long time. We're now seeing it on projects of this scale, Javier. What's changed?
I mean, what it started with the small machines now is reaching the large machines. Obviously, the level of automation is a non-stop way now. I mean, we need to increase the level of efficiency of the machines, and the only way to do that and to operate unmanned is to increase the level of automation of even this kind of large milling machines.
Now, what do we got here then? I mean, this is a part of a 4-machine order, that's going to a company in Canada.
Yes.
What is this?
Well, this is our typical Fox machine, double column machine, with our typical UAV indexing head, but in this case we have an automatic pallet changing system consisting on 2 pallets, one in each side, that may change the part automatically. So you can save completely load and unload, but at the same time you can get the benefits of a moving table, which means higher accuracy and a fully splash work, a full enclosure.
What are they making? What's this company making?
They are producing their own frames for their own machinery. So they are one of the world leaders in forestry machinery, and they have to machine their own frames in a complete automatic way.
And why did you select this machine then? I mean, we're going to see, all of the 4 machines here, but why was this chosen?
Well, basically a double column machine, moving table provides you a high level of accuracy. Also, you can make a full enclosure, so you can control the chips and the coolant inside the machine, so it's a very clean solution. And at the same time, you can increase easily the level of automation with the pallet changing system and the tool changer.
And what is the head technology that you're going to incorporate onto these machines as well? Because it's a big part of the, a talking point around CORREA when we come here is your head technology and its performance in general. So what are they going to have?
Well, I mean, in the Fox family, we can use all kind of head technologies: 5-axis electrospindle heads, 5-axis gear heads, indexing heads. In this particular project, we are using our more standardized milling head, which is a UAD indexing patented milling head.
And what goes into making 4 of these machines? How long does it take you from taking the order? There's so much, I guess. We've got a production line here where they're going through. When will they be shipped?
Well, I mean, the lead time of a project like this is very difficult to predict, but usually because it depends on how is your production level at that moment. But generally speaking, producing these 4 machines, from the moment we get the down payment till the moment we make the pass off here, it may be from 12 to 15 months.
And the solution that you're providing to them, I mean, what's the problem with how they're making it currently then? Is it just not efficient? Because it's a massive investment, and I guess to get a return on investment of that size, you've got to have a big impact with what you're supplying.
Yeah, I think there are 2 main problems with large parts. One is the manipulation of large parts. So the less you are able to manipulate and the more you are able to move the machine around the parts, you increase the reliability, you increase the accuracy, and you reduce the number of errors. And the second is the lack of personnel, the lack, I mean, how difficult it is to find machinists nowadays and how expensive it is. So the more the machine can operate unmanned, the more efficient the solution is.
Yeah, because I guess with like you say, with larger parts, the more times you have to move them from machine to machine, the more chance you've got of giving yourself a problem, I guess. And it's also time consuming, isn't it?
Absolutely, and a load and a load time. Imagine the load and a load time you need to consume in large parts for every part. So here you're saving almost 100% of the load.
Yeah, of course, you're keeping that spindle going all the time.
All the time.
There's also another element to this, is the tool changer. You've actually got a robot, you're using a robot to change the tools.
Yeah.
Why have you considered that as opposed to a normal sort of tool change mechanism?
Well, when you are thinking about a large milling machine working unmanned for example, for 3, 4, 5, 6 shifts in a row, it means that you need to have much more tools because you need to duplicate, even triplicate the same tool. So in case you need to change the inserts, you have no people So the machine should be able to take this tool and change for another new tool and keep working. So, and the reason for that, I mean, and why, and this is the reason why we are installing a robot tool changer here, to increase the capacity of the tools.
But I guess also it's not just tool for tool. I guess you can be a lot more flexible and adaptable with the sizes, the lengths of tools that you actually incorporate into the job, can't you?
Absolutely, because when you automatize the complete solution, you need to change all kind of tools, long tools, bigger diameter tools. So of course, it's not only a matter of number of tools, but also a matter of how can I automatize the changing, or how can I automatic change all kind of tools.
What would be the change time of the pallets on something like this? Are we talking a matter of seconds to go from pallet to pallet?
Well, the changing of one pallet may take a couple of minutes.
So that's really the only downtime you're going to have, because the rest of the time the spindle is going to be in action.
Exactly.
Now what we see here, this is, to me, this screams total flexibility, automation on the whole, not just a milling machine, but now we have a machine that has got a turning table as well, Javier.
Yes.
What's this?
Basically, this is a similar technology with the technology we have seen. It's a Fox milling machine, double column moving table. But in this case, this is even much more complicated, because apart from the automatic pallet changing system that you can see now, we have a milling turning machine. So we have a pallet which can turn as a vertical lathe. And the milling head technology in this case is much more complicated, because we have turning heads and we have milling heads.
Okay.
For example, the head we can see now is a turning head designed for turning the inside of the parts.
And those are housed over there then, I guess. Your head changes are to the left of what we can see there on the machine.
Exactly.
Yeah?
In this case, we are using a conventional tool changer for 240 tools, which is more or less the limit of the traditional tool changing systems.
Okay, and then here's your pallet systems. So this is where you're going to have two pallets here, basically.
Yeah, of course, it's the same concept as the previous machines. We have two pallets, and we can save the load and unload time. And we have one station in which we load and unload the parts.
Javier, who would opt for a machine like this, of this size and of this capability? I'm thinking obviously some, larger casings that need turning, and then they need milled features on them, where you'd have to have done them on a
for example,
lathe.
this is typical for energy sector. For example, power generation or parts of the windmills. For example, the gearboxes, in which you have some transmission parts that have to be turned and milled, and they are very accurate parts. So you try to make everything in one single machine to increase also the level of accuracy and to try to avoid the manipulation of the part itself.
As we move round to what we're going to see, whereas machines that you're supplying a lot into China, what do you think is the reason for this kind of shift change, where you're seeing so much automation here? If we'd have come here, which we did 5 or 6 years ago, we would have seen a lot of your Fox machines going through, and they would have just been single table machines. They wouldn't have had what they've got on them now. What's changed?
But I mean, the technology is evolving now. Now, even the software, the digital twins, the technology permits you to simulate everything before starting into the operation. So it means that the whole technology permits you to increase the efficiency of the machining process. So then the machining process started to be more scientific and less traditional, and also the lack of people.
Well, this is what I was going to say. Is the market is demanding this? Is it here in Europe? Is it demanding it around the world? Do you see patterns in different territories? I mean, for example, we're going to be talking about China now.
It's more common to see in European countries and North American countries the increase in the level of the automation, probably because it's more and more difficult to find people and machinists to run the machines, and even when you find them, it's more and more costly to maintain them.
Because here, these machines here, I mean, the head technology on this is slightly different. 5-axis head here, but this is a single table machine.
Yes.
And this is what you're seeing a lot of impact in the Chinese market.
I mean, true, this is, let's say, more a single table machine, so more a traditional double column machine. with a geared 5-axis head, normally used for cutting in 5-axis hard materials like titanium. And these kind of machines are going to China now more often, because I think China is on the way to increase also the level of automation, but for the moment probably they can get, it's easier for them to get the people.
So this would typically go into the aerospace sector, be machining titanium. You've got a lot of power in these heads as well, haven't you, which is where you see your advantage, yeah?
Yeah, so this is a typical flexible machine for a typical tier 2 for aerospace that needs to cut in 5-axis hard materials. So this head is providing a higher torque, and not only higher torque in the spindle, but also higher torque in the rotating axis.
Rotating, yeah. And this is where a lot of your Fox machines are assembled basically in this area, isn't it? This is, I mean, we're going to see machines here from the UK. We've just talked about machines from China. Here, a machine going into the UK market at the start of its journey, I guess.
Yes.
Yeah. Everything starts somewhere. Here we have the base of a machine.
Yes, the beds. So yeah, we will see, I think, at least 3 units going to the UK,
Okay.
which is good news, of course. And yeah, I mean, nowadays, for large milling machines, there are 2 sectors that are growing continuously, and we see a continuously growth in the coming years, which is basically aerospace sector and the defense industry for obvious reasons.
I mean, you're bursting at the seams here as well. I mean, you've just got a new facility. There's going to be a lot changing here in the next year as well.
We are expanding our assembly capabilities, obviously, because we need to increase our capability, our assembly capability, and at the same time we are making our new machining shop for the future of the future, which will be also completely automatized.
Yeah.
So we will use this technology we are showing today in our own machining shop very soon.
And if we look at this, explain to me this project.
Well,
this way.
again, we are talking about complexity. We are talking about complex machines, and this is another good example. We are talking about the Gantry machine. So this is a Fox, Gantry, Fox M, Gantry. So we are moving the whole bridge. But at the same time, we have 2 working areas. One is a floor plate, and another area is a turning plate of 3 meters of diameter.
Okay, so what we can see here is the turning, you say 3 or 4 meters?
3 meters diameter.
3 meters,
yes.
But also with this, you'd have a floor plate table as well,
Exactly.
which is fixed.
Yeah. So this machine, again, permits you to act as a vertical lathe and as a full milling machine. And on top of that, this machine is equipped with the latest technology in terms of heads. So you can see a 5-axis head with electrospindle, but also we have indexing heads, and we have an automatic head changing system. So this solution is very much complex. Imagine the number of axes involved: turning, milling, 5-axis head, indexing heads all together.
But you're moving this, so the gantry is going to move backwards and forwards,
Yes.
which is going to be your x-axis, yeah?
Yes, and also it will permit you to save load and unload, because you can load one part on the turning at the same time you're milling on the floor plate,
And that's safe?
and vice versa.
That's safe?
It's safe because we have a panel and we have all the software devices to avoid the machine going to the other area when you're loading the part. It's perfectly safe.
Is it slower though than a moving table? But I guess you wouldn't have a moving table here because you've got the 2 tables. What's the differences between that gantry and...
It's normally less accurate because you're moving the whole bridge. It's obviously a little bit slowly, and the enclosure of the machine is much more difficult in the country.
Yeah.
And this is...
But the good thing is you're not moving the parts. You're not having to
sure.
move the weight of the part on the
Yeah,
machine.
exactly. So you can load very, very heavy parts.
And you've got 2 cabins here as well. Two operators. What would that be? One would be for the table here that's turning, and one also for the fixed.
The 2 cabinets is also a matter of ergonomics. So you always can have a perfect view of the component from any angle, apart from the cameras, of course, because we have cameras installed.
Yeah.
But it's important in these complex machines, when you're turning and you're milling and you're making many complex operations with different heads, to have perfect visibility and a perfect view.
Which you can have 360.
Absolutely.
So the next area that we look at is going to be high-speed machining for like the aerospace sector.
Sure.
Again, it's totally different configuration of machine. And that's what I'm actually noticing here. All of these solutions that we're looking at, they're all configured very differently for the reasons that you mentioned. Obviously, they all have their own advantages. what we're going to see here is a machine that is a gantry, but the head is moving. Well, these are, well, you explain, Javier. This is me trying to do your job for you when you're far better at it.
Yeah. So basically, as we were talking before, aerospace sector is growing, defense industry is growing, and this is a typical example of the typical high-speed top gantry machine for the typical tier 2, delivering aluminium monolithic parts for the aerospace industry. So this is a high-speed machine that is able to move 60 meters a minute.
Yeah.
And then we have...
so it's moving backwards and forwards on the rails, basically.
Exactly. We have a very specific construction.
Which would be far quicker than a whole gantry going up and down.
True, absolutely. We are moving much less mass.
Yeah.
So we combine here a very solid and stable structure with a polymeric concrete, and a really top-class driving systems. So we can go fast and we can accelerate fast, because this is not only this is not only moving fast, but is also accelerating fast.
Point to point.
Yeah, to point as fast as possible.
Yeah. And of course, the tables fit the floor better. What's the distances? It's like 10 meters, 12 meters. What's that?
Yeah, of course, this is a modular system. So we have a modular system of beds. So the length of the machine can be starting in 2 meters up to 20 meters.
Where would you keep your tools? I mean, where would you stuff like that? Is it somewhere in the middle, or does it move with the on the bridge?
The tool changer. Yeah. Normally, tool changer is hidden in one of the beds.
Okay.
And we have a drum.
Yeah.
So the drum will the arm of the tool changer will come out, and the machine will go to a certain point to change the tools.
Absolutely fascinating. Let's go this way. And then next, we're looking at a large travelling column machine. This is the Magna series. Where do these go? Where do these fit?
Well, I mean, first of all, Magna series is the largest travelling column family we produce in this factory, and this machine can be assembled up to 8 meters in vertical. Okay. So imagine the size of this machine.
8 meters in vertical. And what is this? What is this one?
No, this one is just 4 meters.
Okay.
So considering a Magna is a small unit, and this machine is going to Germany to the customer in which we installed already the first one, and now we're going to install the second unit, one in front of each other.
Okay. So there would be one here, kind of facing this way.
Exactly.
With a floor plate in between the two
and
of them.
rotary tables in between.
And rotary tables. So why do that? I mean, you machine it from both sides.
I mean, because you can do everything. You can machine one component in one side and another component in the other end, or you can machine the same component with both the spindles at the same time. So you have all kind of
so
possibilities.
Everything is synchronized between the two machines as well.
Yes, and each machine has its own head changing system. Yeah, and head magazine. And you can see also that our head technology is all about customer needs. And you can see even customized heads, like this one, longest node right angle heads, in order to automatize also all the operations. So you can access to a certain areas of the part without the necessity of increasing number of setups.
Okay, so here's your other head options here.
Yes.
And these will be picked out automatically and put into the...
Of course. So we have, as you can see, you have different right angle heads, our UAD indexing heads. So.
Yeah, and what happens here is the column moves up and down, point to point. So I guess, again, the part, however heavy they are, that's not having to be moved on the table. That's in a fixed position.
Exactly. It's like in a gantry.
Yeah.
So the part is resting on the floor plates. So we can put really heavy parts because the machine will be moving around.
And we'll walk this way and we'll see. This is obviously then the base of the machine where the column is moving up and down on, yeah?
Yeah, true. The x-axis is given by the column.
Yeah. And how long could these be?
It's the same, it's a modular system because we have modules of beds.
Yeah.
So it can start in 4 meters and it can go up to whatever, 20.
So you just have multiples of 4,
exactly.
8, 12.
Exactly.
Yeah.
So it's very.
But from one end to the other, do you kind of get any, crabbing's the wrong word, but do you lose any positional tolerance? I guess you must.
No, because we aligned every bed to respect each other. So we use a very precise and very systematic way in how we level every bed together. So from one end to the other end.
So as we kind of come back round now to almost where we started, what we're going to see now, in my mind, Javier, is probably one of the most impressive elements of what we're going to see on this tour. Again, really about automation, and again, it's two machines almost facing each other. What do you call that? What is the terminology?
We call this configuration duplex configuration, and normally this configuration is applied to traveling column machines. So let's say we can apply this duplex technology to small traveling column machines like this one, to larger traveling column machines like the Magna we just saw. So what is this exactly? This is a production unit consisting on two traveling column machines facing each other. Of course, both the machines has its own milling head. Yeah. So both machines will be working at the same time on the same part. And normally these machines are long enough to have two working areas, also to save load and unload time. So again, automation and even higher level of productivity, because you have two spindles working at the same time. And this is typically used for narrow parts and narrow and long parts, typical, for example, for the construction equipment, for boom and arms, which are very long, but you have a lot of holes, yeah, and you have a lot of parts to be produced. Yeah. So,
but what about the communication between this one and this one? I mean, how do you?
There are many things involved. We have some calibration cycles between both the machines, so they can exactly be calibrated between themselves, so they can reach the same position accurately. Yeah. We have at the same time anti-collision and cycles to avoid the collision between both the machines.
And could you have a fixed table and again a turning table, so you've got the flexibility to do all this?
You may have it. You may have it as well. So in between both the machines, you can have everything. You can have rotate tables, turning tables, floor plates.
And where is this going? What are they making?
This is going to Estonia, to one manufacturer also of construction machinery. So they're producing a lot of welding, narrow and long parts, and they have a high production. So they need to have this high end system.
I guess you can make it twice as fast because you've got two spindles making
almost twice.
Yeah. WEC. Now, when we were at MAC, this is a customer from the UK that ordered. How many machines was it that they purchased?
I think at that time we signed the agreement for 4 machines, and they are becoming one of our best customers in the UK so far.
And these are them on their journey of being built now.
Yes.
So if you're watching this, guys.
Yeah,
these are the machines.
So we have one traveling column axis machine being produced now for WEC, and then we have one beautiful Fox-M Gantry machine being produced now. You see the crossbeam and the Z and Y axis now being assembled.
Yeah. And why did they pick the two different styles of machines? What was the reason behind that?
Well, because they are becoming one of the largest subcontractors in the UK. So when you're a subcontractor, you provide services, machine services to other companies. So then you need obviously to have different machine configurations, yeah, to be able to produce all kind of different parts for your customers. So you need a huge flexibility. So,
in summary, then, Javier, can you see you're going to be moving into a new factory next year? You're going to have you're going to be doubling your opportunity to output twice as many machines, or will it be, the same amount of machines but with just a lot more automation on them? And let's finish up where we started here, because we can see this pallet system actually moving. Yeah, what does the future hold? When I come back next time, which hopefully won't be too long, what are we going to see?
Yeah, so we are increasing our capacities just because of the 2 reasons you just mentioned. One is to be able to produce more machines. That is clear, because we just reach our productivity capability here, and also because the machines are becoming more and more complicated. So we need more and more space for one single unit to be assembled. So also we need more space and more capability to produce this kind of complex machines.
Yeah. Will there be any new machines coming out from you, or will what we've seen today still continue to be your range with these elements added to them? Is that where your investment as a business is coming now, is to develop what you've already got to be able to offer more unmanned running, I guess?
Exactly. So in our future, in our machining shop of the future, we are going to use our latest state-of-the-art automatized solution apart from being more efficient in our machining and increase the level of unmanned operations to show our customers, like a showroom, to show our customers what the automation can provide.